We shall now commence this module by studying about the theory of production, law of diminishing returns. Today, one of the key concerns of the business managers is to achieve optimum efficiency in production or minimizing cost for a given output. In competitive market, a firm can survive only if it is able to produce goods and services at a competitive cost. Hence, business managers should make an effort to minimize the cost of production or maximize output for a given level of inputs. There are some basic questions which managers are confronted with while endeavoring to minimize the production cost. These are: first, how does output change with the increase in quantity of inputs? Second, how can production be optimized to achieve reduction in cost? Third, how does technology helps in minimizing the cost of production? Fourth, how to achieve the least cost combination of inputs for a given output. The theory of production seeks to explain answer to these questions with the help of economic models that are built under hypothetical conditions. The production theory provides various tools and methods to analyze relationship between input and output, which provide directions to find solutions to practical business problems. After studying this module, you would be able to know about the production function, derive the relationship between AP, MP and TP, learn about the law of variable proportions, learn about stages of production. Let us discuss some basic concepts of production theory. Production. In economics, the transformation of resources, men, material, time and so on into a different and more useful commodity through a process is called production. In general, the production function is limited to only manufacturing, in which inputs, labor, machine, raw material, time and so on are transformed into an output. In economic sense, there are different forms of production other than manufacturing. When a commodity is transferred from one place to another for consuming in the production process is production. For example, when sand is transferred from the river bank to construction site by the sand dealer, this activity too is production. When a commodity is stored for future consumption or sale, this is also called production. It is not necessary that only physical conversion of inputs into tangible goods take place in production process. Some types of production involves conversion of an intangible input into intangible output. For example, both input and output are intangible in the production of medical, legal, social and consultancy services. Next, fixed and variable factors of production. A variety of goods and services are used by a firm in the process of production called factors of production, or inputs such as land, labor, raw material, plant and machinery, factory premises, tools and equipment, etc. These factors of production can be classified into two parts. First, fixed factors. Second, variable factors. Fixed factor is one whose quantity remains the same irrespective of the level of output. Its quantity cannot be readily changed in the short run. On the other hand, a variable factor is one whose quantity changes with the changes in the level of output. In the short run, a larger quantity can be employed by the users of such factors. For example, a firm wants to increase the production of books from 1000 to 2000 daily. To do so, it will need more factors of production. But there are some factors whose supply cannot be increased immediately. Example, printing press, building, etc. Therefore, the firm will have to use those factors whose quantities can be increased immediately, such as labor, raw material, etc. In the given example, printing press and building are fixed factors of production. Labor and raw material are variable factors of production. Short run and long run. Short run refers to that time period in which supply of certain factors is fixed. That is, it cannot be increased or decreased. For example, plant, machinery, building, etc. Therefore, a firm can increase the production of a commodity in the short run by increasing the use of variable factors such as labor and raw materials. Long run refers to that time period in which supply of all factors, that is fixed, and variable is elastic, but not sufficient to allow a change in technology. In the long run, no factor is a fixed factor. All factors are variable. Therefore, a firm can increase the production of a commodity in the long run by increasing the use of both variable and fixed factors of production. There is another term, very long run, used by economists, which refers to that time period in which technology of production can also be changed. The production function also changes in the very long time period. Let us now understand the production function. Production function is a mathematical statement used to explain the technical relationship between input and output in physical terms over a given period of time. According to Kotsianis, the production function is purely a technical relation which connects factor inputs and output. The general form of production function tells that output of any commodity depends on quantity of inputs and techniques of production. Given the state of technology, several methods using different combination of factors are used in the production of a commodity. For example, the production of cloth requires cotton or polymer or silk as raw material with power loom, hand loom or even computerized machines. The same product can be produced in several possible ways using different kinds of raw material and technology options. Thus, there can be various technically efficient methods of production. Production function incorporates all such technically efficient methods. Production function is a schedule showing maximum output of a commodity produced per unit of time with each combination of inputs and with the given state of technology. A different set of inputs are used to produce a given level of output, and each of these sets may be technically efficient. Suppose a manufacturing firm employs only two factors, labor L and capital K in manufacturing steel chairs. Then, general form of its production function can be written as Q is a function of L and K, where Q is equal to quantity of steel chairs produced, L is equal to labor, K is equal to capital. The above production function shows that quantity of steel chairs produced depends on the quantity of labor L and capital K employed. The production of steel chairs can be increased by increasing K and L. The time period, that is short run or long run, considered for increasing production is used to decide whether both K and L or only L will be increased. In the short run, production of steel chairs can be increased by employing more of labor only. The production in the long run can be increased by employing more of both capital and labor as all factors are variable in the long run. Accordingly, production function can be of two kinds. First, short run production function. Second, long run production function. The short run production function can be written as Q is equal to the function of K and L, where K means that capital is fixed in amount. The long run production function can be written as Q is a function of K and L. The production function is based on some assumptions. These are: first, there is perfect division of both inputs and output. Second, only two factors of production are employed, capital and labor. Third, imperfect substitution between labor and capital. Fourth, technology is given and constant. Fifth, in the short run, supply of fixed factors is inelastic. The production function will have to be changed if there is some change in these assumptions. Moving further, let us now study about the production function with one variable input. In the short run, producers can change the output by changing variable factors only. Let us suppose a firm uses two factors, labor and capital, where labor is variable and capital is the fixed factor. If labor is increased to increase the output, keeping the amount of capital unchanged, then there will be a change in the ratio in which these factors are used. Thus, output can be changed through a change in labor only. This type of production function is also known as variable proportion production function. It is essentially a short-run production function which shows maximum output that can be produced by changing the quantity of variable factors, keeping other factors fixed. The short-run production function can be written as Q is a function of K and L. Total product TP. It can be defined as total quantity of goods that can be produced by a firm during a specified time period. TP of a firm can be raised by utilizing more and more units of the variable factor, that is labor. As can be seen in figure 1.1, TPL increases at an increasing rate in the beginning with the employment of more and more of variable factor. After a point, it starts increasing at a decreasing rate with further increase in the use of the factor. It is not necessary that total product will always increase with the increase in the quantity of variable factors. For example, if a firm employs labor that are beyond the capacity of the factory, then they will not be in a position to work efficiently. Thus, TPL curve slopes steeply upward at first, reaches a maximum and then starts declining. Next, marginal product MP. Marginal product is defined as change in total production due to use of an extra unit of a variable factor. For example, when 10 laborers were employed in a firm, total production of chairs was 1000. Now, if one extra labor is employed, total production increases to 1050 chairs, attributable to 11 laborers. Since 11th labor has added 50 chairs to the total production, the marginal product of 11th labor is 50 chairs. The marginal product of labor can be written as MPL is equal to change in total product upon change in labor, which is equal to delta TPL upon delta L. The formula for calculating MPL is MPL for nth unit is equal to TPN minus TPN minus 1, where N stands for number of labor units. Marginal product rises in the beginning. When total product is maximum, it becomes 0. Here, total product is not increased with the use of extra units of variable factor. Ultimately, marginal product becomes negative when total product declines. The diagram shows the TPL curve and the derivation of APL and MPL curves. Average product. Average product of an input is total product divided by the total quantity of labor employed to produce this output. It measures on an average how much output is produced by each labor. Thus, APL is equal to total product upon labor input. As can be seen in figure 1.1, like marginal product, average product also rises initially and then falls. It is inverted U-shaped curve and can never be 0 or negative. Relationship between TPL, APL and MPL curves. With the help of TPL curve, we can derive APL and MPL curve as graphically illustrated in figure 1.1. TPL is total product of labor curve. Here it is assumed that only variable factor is labor and the amount of capital is fixed K. TPL rises when quantity of labor increases, but the increase becomes smaller and smaller. Relationship between TPL and APL curves. First, APL at a point is given by the slope of the straight line from the origin up to a point on the TPL curve. Till point A, the value of the slope increases and after that it declines. Second, in the beginning, APL curve increases, becomes maximum and then declines. Third, APL is positive as long as TPL is positive. Fourth, it is always greater than 0. Relationship between TPL and MPL curves. First, MPL at any point on total product curve is the slope of the tangent at that point, or MPL between 2 points is the slope of the line joining the 2 points on TPL curve. Till point C, the value of the slope increases, then declines until TPL is maximum. MPL is 0 at that point and after that it becomes negative. Second, in the beginning, MPL increases, becomes maximum when the slope of the tangent is steepest and then falls. Third, MPL is 0 when TPL is maximum and become negative when TPL declines. Fourth, area under MPL curve gives TPL. Next, relationship between APL and MPL curves. First, in the beginning, when both APL and MPL curves are increasing, MPL increases greater rate than APL curve. Both curves increase till fixed input K is underutilized. Second, both APL and MPL curves decline, but MPL curve declines at a higher rate than APL curve. Third, MPL is equal to APL when APL curve is maximum. Fourth, when MPL starts falling, APL continues to increase. Let us now discuss the law of variable proportions or diminishing marginal returns. In the traditional theory of production, the law that studies the input-output relations with one variable factor, say labor, keeping the quantity of other factor, say capital, constant, is called the law of variable proportions. The law of variable proportions states that when the quantity of variable factor is increased, keeping the quantity of fixed factor constant, then increase in total product will eventually decline. In other words, total output increases at an increasing rate up to a certain point, but after that point, it increases at diminishing rate. According to G.L. Thurkettle in Basic Economics, if increasing quantities of one factor of production are used in conjunction with fixed quantity of other factors, then after a certain point, each successive unit of a variable factor will make a smaller and smaller addition to the total product. Assumptions. This law is based on certain assumptions. These are: first, there is only one variable factor. Other factors are held fixed or constant. Second, the variable factors are homogeneous. That is, each unit is equal in efficiency. Third, it is possible to change the proportion in which the various factors are combined. Fourth, the short run time period is assumed, as in long run it is possible to vary all factor inputs. Fifth, the state of technology is given and constant. Sixth, there is no change in prices of factor of production. Next, stages of production. In the short run, a firm can change the output by changing the quantities of the variable factors, while quantities of other factors remain unchanged. The behavior of output can be explained in 3 stages. The diagram shows the 3 stages of production. Stage 1, stage of increasing returns. In this stage, TPL increases at an increasing rate up to point C. MPL rises in the beginning and reaches its maximum point. APL pulls up due to rising MPL. Beyond point C, TPL increases at a decreasing rate. MPL starts declining but is positive. The point C is known as the point of inflection. After this point, APL continue to increase because MPL is higher than APL. The stage first ends when APL reaches its maximum and is equal to MPL. In stage first, the amount of fixed factor is abundant in relative to the variable factor. Since fixed factor is not fully utilized, therefore, producer has an incentive to increase the output by employing more and more units of the variable factor. This will result in more efficient use of fixed factor. Thus, a rational producer will not choose to operate in this stage because by expanding the level of output, he can further reduce its average cost. Causes for increasing returns. The two important reasons for increasing returns are given below. First, indivisibility of fixed factor. It means a minimum size of fixed factor need to be employed irrespective of the level of output. In initial stages, the minimum size of fixed factor is too large than its actual utilization. This results in underutilization of fixed factor. By employing more and more units of the variable factor, the fixed factor is utilized effectively and efficiently. This causes output to increase at an increasing rate. Second, specialization. Specialization is the another reason for increasing returns. When the quantity of variable factor increases, the scope of specialization also increases. The various advantages offered by specialization include productivity, efficiency, better skill, etc. Next, stage second, stage of diminishing returns. In stage second, TPL increases at a decreasing rate and reaches its maximum point when this stage ends. Both APL and MPL declines but not negative. This is the reason why this stage is known as stage of diminishing returns. APL is greater than MPL throughout the stage. The stage comes to an end where MPL is 0 and TPL is maximum. Stage second is the relevant stage of operation for producer as efficiency of the scarce factor, that is labor, can be maximized. Next, causes for diminishing returns. The two important reasons for diminishing returns are given below. First, the non-optimal proportion between fixed and variable factors. Once the optimum combination of variable and fixed factors is reached, further employment of labor leads to non-optimal proportion of fixed factor with the variable factor. As a result, efficiency of variable factor starts decreasing as fixed factor or indivisible factor is being used to full extent. Second, elasticity of substitution between the factors is finite. If the fixed factor is perfectly substituted by the variable factor, then the inadequacy of the former could be compensated by increasing the use of latter. But elasticity of substitution between factors is finite. Therefore, if firm employs additional variable factors beyond the optimum combination, then productivity of variable factors decline as the availability of indivisible factor per unit of variable factor decreases. Stage third, stage of negative returns. In this stage, total product falls. MPL becomes negative and falls below the x-axis. APL falls continuously but is non-negative. A rational producer would not like to operate in this stage as the efficiency of both fixed and variable factors decreases and the proportion between factors is highly suboptimal. Causes for negative returns. The two important reasons for negative returns are given below. First, suboptimal ratio. In this stage, the quantity of variable factor is too much in relative to the fixed factor. As a result, the efficiency of not only variable factor but also fixed factor starts declining. As a result, total product starts falling. Second, moving beyond optimum degree of specialization. If the limit to optimum degree of specialization is crossed, then the efficiency of variable factor declines. Let us now recapitulate what we have learned so far. The transformation of resources, men, material, time and so on into a different and more useful commodity through a process is called production. Fixed factor is one whose quantity remains the same irrespective of the level of output. Its quantity cannot be readily changed in the short run. A variable factor is one whose quantity changes with the changes in the level of output. Short run refers to that time period in which supply of certain factors is fixed. That is, it cannot be increased or decreased. For example, plant, machinery, building, etc. Long run refers to that time period in which supply of all factors that is fixed and variable is elastic but not sufficient to allow a change in technology. Production function is a mathematical statement used to explain the technical relationship between input and output in physical terms over a given period of time. Production function can be of two kinds: A. Short run production function, B. Long run production function. Total product is total quantity of goods that can be produced by a firm during a specified time period. Marginal product is defined as change in total production due to use of an extra unit of a variable factor. Average product of an input is total product divided by the total quantity of labor employed to produce this output. The law of variable proportions states that when the quantity of variable factor is increased, keeping the quantity of fixed factor constant, then increase in total product will eventually decline. The behavior of output can be studied in three stages: A. Stage of increasing returns, B. Stage of diminishing returns, C. Stage of negative returns. Stage second is the relevant stage of operation for producer. Thank you.